get the show on the road today. So the agenda for today is to finish up talking about some of the notation associated with entity relationship modeling, and then go through a case study to show you kind of how you might set up a entity relationship diagram when you don't get to look at the relations. So last lecture, I kind of could show you how to generate an ER diagram because you already had the relations in front of you, which made it easy to spot relationships. But typically, you just have a description of the problem, and from that, you're trying to derive the ER diagram and the relationships. But before we do all that, we first need to just finish up talking about a couple things with the ER modeling. First of all, okay, so we are talking about participation rates, so multiplicity and degree of a relationship. So multiplicity is the number of entity occurrences in a relationship, and then the degree of the relationship is the, a little hard, come on, is what happens when you take the maximum participation rate on both sides. So you first, when you're coming up with relationships and participation rates, you start by doing the multiplicity. Figure out the minimum number, which is the participation rate, and the maximum number of entities that can occur in the relationship. The maximum is the cardinality and the minimum is the participation. Once you have that, then you can determine the degree of the relationship, which is the maximum cardinality on each one. So going back kind of quickly, we had this example of staff managing a branch. So a staff member can, some staff members don't manage any branch, so the participation rate is 0. And you can manage at most one branch, therefore the maximum or the cardinality is 1. On the other side of it, a branch is managed by a minimum of 1 staff member and a maximum of 1 staff member. And from that, you can get that this is the degree of this relationship is 1, 1, because, see this just a second. But it's not working. Huh. Well, it's not playing nicely with PowerPoint. Well, you just have to take my word for it. So it is a 1-1 relationship right here. The degree of this relationship is 1-1. And we can have also one-to-many. So for example, the branch staff relationship is one-to-many. One branch employs many staff, and you can have many-to-many. The example was a newspaper advertises 1 or more properties. So this one right here is a many-many relationship because a newspaper may advertise 1 to many properties. A property for rent may be advertised in 0 newspapers if it is already leased and therefore not being advertised. It could be listed in many newspapers. So the cardinalities for both of them is many, hence it's a many-many relationship. So binary relationships are the easiest ones to come up with. And we already did that for that one. Here's another one. So this is staff oversees property for rent. So a staff member may be assigned to 0 or many properties to manage. Conversely, a property may be managed by 0 or 1 staff. Maybe if the staff member has been fired temporarily, there may be no one actually overseeing that property. So as maximum 1 person oversees the property, it may be no one. And we call this a one-to-many relationship because one staff may manage many employees. And this is our many-many relationship that I just talked about. And again, a common mistake from last time is that the wrong way to show a many-many relationship is to actually show the relationship as an entity. So here I've shown the advertisement as an entity and saying that a newspaper lists one-to-many advertisements and that a property for rent appears in 0-to-many. It's not an entity. Advertisement is a relationship between newspaper and property for rent. And I said last time, a good way to recognize that it's probably a relationship rather than an entity is if it's a sync node. So in general, it's not always the case, but if an entity is a sync node and has a one-to-many, or I'm going to say many-to-one, because it's the many part, many-to-one relationship. With multiple entities. There is a good chance it is not an entity but a relationship. Not guaranteed, but just there is a good chance that it is a relationship among these entities. And not a entity itself. So you should always check if you see a sync node with multiple many-to-one relationships, good chance that we're looking at a relationship. Okay, so then we move on to the multiplicity for complex relationships. And there we have something that looks like a ternary. So we call a complex relationship something that involves more than 2 entities. So here we have the 3-way relationship of a staff registers a client at a branch, and we have to figure out what the multiplicity is. And the way we do that is we basically take a we fix an entity from all but one of the entities, and then we figure out how many occurrences of the remaining entity there can be. So here, let me put this on the notebook. We have a staff and a client and a branch. And we have this as a registers relationship. So to figure out the multiplicity that should go there, what we do is say, pretend we have a specific staff like SG 37, registering some client, say Brad. Well, the question is, how many branches could there be where staff member SG37 registers Brad? And hopefully you realize the answer is 1 and exactly 1. Okay? There's not 2 branches where a client basically arrives at a branch and is registered. So one staff member helps that client register. So now we want to figure out this one. So again, we take the remaining entities, which are staff and branch. So say again, SG37 in a branch, say the London branch. And we ask how many clients could SG37 have registered? Well, a bad one may have registered none, or may be a manager who doesn't work with clients. And a good one, presumably, has done a lot. So 0 to many, because one person at one branch could presumably register 0 to many clients. And finally, this one, okay, we'd say a branch and a client. So at some branch London, some client Brad. Okay, and the question is, how many staff members might have registered Brad at the London branch, and what do we think the answer to that is? What's the minimum number that could have registered me? 1, and what's the maximum? 1. So it's 1 ... 1. So that's how you figure it out. You essentially figure out for a specific instantiation of, so basically create an instance of an entity for all the remaining entities, create a tuple from that, and then figure out how many instances of the entity can exist, minimum and maximum, and you have your multiplicity for that particular entity in the relationship. Okay, and I know it's not easy. It took me a little while to become comfortable with it. So it's not necessarily something you're going to get right the first time. It will take some practice. Okay. The other thing is you should know that occasionally it's not a minimum of 1 and a maximum of something. For example, we might say that a student must take a minimum of 3 courses and a maximum of 5. So if we said that, we would show a relationship that way. So if we said, for example, a student enrolls in courses and we say specifically a student must enroll in a minimum of 3 and a maximum of 5, we'd write it like that. And in this case, it would still probably be the case that the other way it was 1 to many. But maybe not. Like many courses have an upper limit. So maybe it would be 1 to 100. But that would be a general limit on all courses. It wouldn't be a limit on a specific course. So not always is the minimum rate 0 or 1, and not always is the maximum rate 1 or star. Yes, Greg?
Specify that the maximum would be based on some attribute of the course?
No, I've actually never seen it that way. So it's more of a general constraint. Yes?
What would you do in the case of like where the course had like a max X attribute?
A max what? Max?
Like where you have a constraint that there cannot be more than X.
Students in that class, correct?
Yes, in that where X is an attribute in the course.
I would have to think about that, Demi, actually. It's a good question, and off the top of my head, I don't know the answer to that because it's not a constraint, a general constraint on the attribute. It's a constraint per course. And I think what you would have to do is actually create another relation with the maximum enrollment caps. So I think what you would do is have like something like max enrollment. And you would probably have course ID and like cap. And then you would have something based on that cap. But I would have to think about how you did that. You could enforce it programmatically by never allowing an insert to occur if the cap was exceeded. What I would have to figure out, I don't want to do it online, is whether I can write a constraint that ensures that. I probably can. Given that I have a relation like this, I can probably write an aggregation constraint that is probably going to guarantee it.
Okay.
So let me think about it, though, rather than trying to come up with it off the top of my head. Other questions? Okay, so that's just kind of that summary where it doesn't always have to be 0, 1, or 1 many. You could have specific numbers down there. So then we move on to some common problems with ER diagrams. I actually already talked to you about one, which is that you represent a relationship as an entity when it's really a relationship. So that one is where you have effectively a sink node. There's two other problems that are often called connection traps. And the two main types of connection traps are fan traps and chasm traps. And you often will write it down a certain way and then realize that you could have reinterpreted the relationships to get it in another way. So the fan trap occurs when you have an ambiguous pathway. A chasm trap occurs when it looks like you have a path between two entities, but it doesn't necessarily exist. And we'll illustrate both of those. So here's an example of a fan trap. And the issue is that you think, so you have a division has staff and a division operates branches. And you think you should be able to write a query that finds out which branch a staff member belongs to. So that seems like a reasonable query to write. Okay? But if we actually try to do it, this is called a semantic net, which is actually showing specific examples. So we have SG37 belongs to Division 1, and Division 1 is operating 3 branches, B3, B7, and B5. So the question is, which branch does SG37 belong to? Can you tell me? Based on this? No. What are the possible branches? You can narrow it down. It could be B3 or B7, but we don't know for sure which one. So this is called a fan trap because it's a piece of information that we should have in the database. We should be able to answer the question at which 37 work, but we can't. So in this situation, we need to go back and see if perhaps we can't redo the ER diagram. So here we have arrows coming out from division to staff and division to branch. But if you think about things, the problem here is we think that a branch employs a staff. So the relationship that we really want is that a division operates branches and branches in turn employ staff. So now we have a nice way to get from staff to branch, and we can still find out which division the staff member works in by going through its branch relation. So if we look at it now, we see that staff 37 works at branch 03, and we know that branch 03 is in division 1. So now we can answer both questions: which branch does a staff member work at, and which division does that staff member work for? Okay, so it basically, the issue originally was that it was a straight line, and it somehow seemed we should be able to extract the information, but there was no directed path from branch to staff. When we changed it, now there was a directed path going from division to branch and branch to staff. So there was that path now. Okay, then the second common example of a problem is this chasm trap. So here we have a branch has one-to-many staff, and a staff can manage some number of properties. And a question we might legitimately ask is, which branch manages some property? Okay, so let's again look at what's called a semantic net. And here we have a property, PA14, that's not managed by any staff. And because it's not managed by any staff, we can't determine which branch manages it. Now that's not necessarily a good thing. If the property, typically the property is being managed by a branch, for example, it's managed by the London branch, and it just may be that the staff member was fired or reassigned to another branch, and temporarily this property doesn't have someone overseeing it, but it's still associated with the London branch. Okay, so the issue is that no one oversees it. So even though there appears to be a link here from staff to property for rent, the fact that there could be no staff member right here overseeing it, this 0 right here breaks the link. So it's possible that what we really have in some cases is this situation: branch, staff, but no property for rent being managed by a staff member. And in that case, it's called a chasm gap or a chasm trap, because there's your chasm. There's no way to get from property for rent back to other important parts of the database. And the answer to that problem is to add an explicit link from branch to property for rent. So now every property for rent will include the branch that is offering it. So not only will it have the staff member overseeing it, but it will have the branch that offers it as well, and therefore we're able to answer the query. So this trap becomes evident when you start trying to say, okay, what queries could we ask, and realizing that certain queries aren't answerable given the ER diagram that we've drawn. So then we can modify it. So this removes the chasm trap. Now it introduces another problem. Can anyone tell me what is the problem this solution introduces? So think about what information a property for rent is keeping. It's keeping a staff number and it's keeping a branch number, correct? Okay, so what's the problem with that? Yes, Greg? The branch numbers could conflict. Yes, so let's say that the staff members at well, shoot. So let's say that now we've done this. Let's say that the staff member who manages the property is at B003, but I say that the branch is B005. That's a conflict. So I've in effect solved the chasm gap by introducing redundant data. And if I am not careful, this redundant data could conflict. Okay, so for example, I might update the staff members branch from, maybe originally it was B005, but I updated the staffs to B003, but the branch is still B005, and now there's a conflict. So solving the chasm trap can introduce redundant data, and there's no way around it. You have either the chasm trap or you have the problem with redundant data. Here, probably we decide we need to have the redundant data because we need to be able to answer which branch manages this property. Okay, there was no problem with the fan trap. The solution to the fan trap was redirecting some edges in the relationships. That was fine, not an issue. But with the chasm trap, the only way to resolve it is to add redundant information to the database. Demi, it looks like you had a...
Yeah, let's see. Could you solve that by breaking each of the relations down into simpler ones?
But that's pretty simple. You have a property for rent is managed by a staff member. I don't think you could get much. I think the answer is no. I don't think you can get around this. So, I mean, this is a binary relationship. So I could imagine if you had a ternary or quaternary relationship, you could try to simplify it, but you can't do it with a binary relationship. That's the simplest relationship you can have. Other questions? Okay. So that kind of concludes the discussion of the notation associated with ER diagrams. What I wanted to do next was actually consider an actual study. So this was a test question I gave once, and the story behind it is I don't think anyone came anywhere close to getting this question right on the exam. So figure it's good to go over this before you hit it on the homework assignment. So I'm going to assume you read this because I told you to. And if you didn't, you better read fast now. So you're basically given this description of a problem and then asked to answer some questions about it. You're asked to figure out what the entities are, what the primary and foreign keys are, and what the ER diagram for it is. Now, the foreign keys, as I've told you, are probably going to depend on the relationships that you draw. Remember I said that if there's a relationship between two entities, there's probably a foreign key involved. And I also told you that if I draw a arrow, say from branch to staff, then there's a good chance that the foreign key is in the staff, because I typically draw it from the one to the many, and therefore the foreign key is going to go in the many. So before I can answer my question about foreign keys, I'm probably going to have to do my ER diagram to figure out what the relationships are. So what I encourage you to do is when you see something like this, you kind of go through it and you try to tentatively say what are entities, what are attributes, and what are relationships, because those were the big three with the entity relationship diagram. Entities, relationships, attributes. Okay? So if we're going through here, we see one and we see that the firm has a number of offices. Huh. Now let's see here a second. Does it work on here? Okay. Hold up for a moment. Okay, so we are back. So we have that, we kind of look through each thing in turn. So we see that a firm has a number of offices. Offices certainly seems like an entity. And we see that each office has a number of investment advisors who service investors. Investors own stocks. Okay, so for sure it seems like each of those should seem as though it is an entity. Okay, dividends, we're not quite sure, but what would you tend to think a dividend is? A stock or an attribute? So it's probably an attribute of a stock. Okay, and there's also some interesting things. Each office has a number of investment advisors. That sounds like it might be a relationship because it has some number of advisors. And advisors who service investors, that sounds like it could also be a relationship. So I'm just kind of going through and annotating this right now, figuring out what might be what. So B says an office is managed by one of its advisors. What does that sound like? An entity, a relationship, an attribute? It's going to be generally one of the three. It's a relationship. It sounds like a relationship. I'm going to put an R there. It sounds like that it's a relationship between two of our entities, offices and advisors. Okay, C, an investor has a name, a unique investment number, an investment advisor, and owns 0 or more stocks. So, what does C seem like? Some attributes. Certainly these are attributes. Okay, this is more like a relationship. Even if you say it's an attribute, if it was an attribute, what is it? What kind of attribute? Remember, there can be composite, there can be simple, there can be single-valued, multi-valued, derived. It would be multi-valued if it was an attribute, but it seems more like it's talking about an entity, so it seems more like it's going to be a relationship because we're talking about an entity. Generally, entities aren't attributes. They're relationships. Okay? So if it mentions something as a entity, it's almost certainly a relationship. Now, it'll probably be represented somewhere as a foreign key, but it's still a relationship. I saw a hand going up.
I was just going to
Okay,
ask you,
yeah.
if it's an entity, does it have to be a relationship?
Pretty much. It's a pretty strong rule of thumb. So now we have each investor's holding of a stock contains information about the stock's ticker symbol, stock's name, number of shares of stock, dividend per share. Okay, so what does this sound like? Something complicated, right? Something that you might initially want to skip over. Okay, so we'll skip over it for the time being. go on to easier stuff. So E, an investment advisor has a name, unique advisor number, one or more investors, and an office. So we can break this one down. How do we break it down? Based on, not Philip. Next to Philip, I forget your name. I want to say Ty, but is it Andrew? Sorry. Andrew, based on your rule, what should we say in E? Which are attributes and which are relationships?
Names and attributes.
Mm-hmm.
Unique advisor number would be attribute.
Very good.
Primary key.
Mm-hmm.
It will be a relationship will be the next one.
Yep, one or more investors, because investors is
A relationship.
and this is a relationship, and office is a entity, so that looks like a relationship. Okay, an office has an office number and an address, Jaja. Are the attributes entities or relationships for F?
The office number is attribute.
Mm-hmm.
And address.
They're both attributes. Very good. Okay. G, an advisor is associated with only one office. J, what is that? Relationship. Okay, an office may have multiple advisors. Philip. Relationship, because advisors is a relationship between office and advisors. Okay. And I, the dividend per share is determined by the stock. Well, we already said up here that it looks like that is an attribute. Okay. And unfortunately, details is right. Let's see, is there any way that I can get rid of anything? Ooh, yes. But not enough. Well, maybe. No. Darn it. Okay, well, you got this all down, hopefully, because it's about, whoops. I have to erase all of it. There's no way around it. Got to erase it. So hopefully you have it down. I am recording it, yes. Okay, J, when a stock gets purchased or sold by an investor, we record the stock's ticker symbol, the transaction price, the date, the number of shares purchased or sold, the investor who purchased or sold the stock, and the advisor who conducted the transaction. Wow, that's a mouthful. Okay, but here's a tip-off. When a stock gets purchased, it's a big verb. It's sounding a lot like this is a relationship. Okay, when a stock gets purchased or sold by an investor, just a sec, Greg, I'm going to finish this. Stock gets purchased by an investor and the advisor who conducted the transaction for the investor. So it sounds like a stock gets purchased by an investor, or an advisor purchases a stock on behalf of an investor, sounding like a relationship. And remember that a relationship can have attributes. So sounds like the attributes for this are the stock's ticker symbol, the transaction price, the date, and the number of shares purchased or sold. So those sound like attributes of a relationship. But you should strongly suspect relationship here because of all of the entities that are being mentioned. And it looks like it's what kind of relationship? Binary or ternary? It's a ternary relationship. It involves three entities. Greg.
So in part D, it says that you don't care about the individual transactions, but then you've got a bunch of information about the transactions. Would you not ignore it since you said you don't care?
Okay, so there's a difference between keeping track of the transaction somewhere and keeping track of it in the individual customer's account. So what I know, it was a little confusing, but I didn't want to keep track of, you'll see when I set up the relations. I probably didn't word this artfully. Actually, I don't believe that this is my problem. I believe that this was the example I took from the book. So we'll say the book. We'll pass the buck. But yeah, so we'll say this wasn't exactly artfully done. But basically, we want to keep track of individual transactions, and then also for an individual investor, we need to keep track of their cumulative holding. So the answer, Greg, is usually when you get if you have a brokerage account, normally it shows you your actual holdings, okay? Like IBM purchased on 3/21/16, 500 shares, purchased on May 25th, 200 shares. That's what they're trying to say, is you don't need to keep track of what they currently own. Transactions, you can figure out what they currently own from the transaction record. So they want to keep the transactions, and then from that, they can figure out what the holdings are. So really, we do not care about the individual holdings. We don't care about the lots. So even that is still, I don't know, something would have to be done. But basically, we care about all the transactions. We just don't care about explicitly representing which specific lots they currently hold. Okay. So going back to D, we can take a crack at D now. So the tip-off here is it's going to be a relationship because it says investors holding of a stock. So that's looking very strongly like a relationship. Okay? And it's containing information about the ticker symbol, stock's name, number of shares owned, and the dividend. So it sounds again like this is actually a relationship that has attributes. So anytime you see a sentence that involves two or more entities, there's probably a relationship in there. And then it's a matter of figuring out, are the attributes associated with a specific entity or with a relationship? Great. Yeah. Okay, so we're pretty much ready to go at this point because we know what the entities are. They are basically, well, I have to get rid of the ink. So this one pretty much, A gave it to us. Offices, advisors, investors, and stocks. Okay, what is not an entity is a firm. So this is going to get some of you. It does every semester. So some of you are going to want to claim that the firm is an entity. The firm is a database about the firm. The firm itself is not an entity. Okay? If you want to model the firm as an entity, then think exactly what relation. There's got to be a relation associated with it. Okay, what information are you putting in the relation? First of all, it's only one tuple for sure, because we only got one firm. And then, well, nope.
A firm has a number of offices.
I understand that, which is what gets a lot of you down the primrose path. But firm is not an entity in this case. The database is representing the firm. But the firm is not an entity. Yes. Okay, so let's say that, yeah, so if you were, let's say you're Kayak, the website Kayak, and you're tracking multiple airlines, then each airline is an entity. But if you're simply American Airlines, you're not an entity. So yes, there could be situations where you have some number of firms, but this is not it. This is the firm. So it's not. Demi.
So basically, the reason that the firm is not an entity is because there is only one.
Yes, and because it's the database.
Okay.
It's the reason ultimately is because it's the database. The firm is kind of the database. So it kind of also comes down ultimately to there's only one instance of it. So it's not itself an entity. It is the database. So yes. Mm-hmm.
Do you think that this diagram will have two relations for one customer, in which one relationship will have the transaction and one relationship will have the accumulated?
Yes, you'll see that there's going to be two relationships involving an investor and a stock. I think that's what you're asking. There is. And just like there will be two relationships between an advisor and an office. There will be an office is managed by an advisor and an office employs advisors. So there will be two relationships there too. But yes, you got it. Okay. So we know the entities. A second. Let's get rid of. So if we're drawing this, we know that we have offices, we have advisors, we have stock, and we have investors. So those are our four entities. And based on what we said, going back here, we know that an office is managed by one of its advisors. So in B, an office is managed by one of its advisors. So an advisor manages an office. And going to, let's see, we see that each office has a number of investment advisors. So an office will say employs advisors. We know that from 3, an investor owns 0 or more stocks. So we can say an investor owns, and in fact, we also can do the participation rate pretty easily. Owns 0 to many stocks, so it gave us the multiplicity for us. So 0 to many. Then, so D is just expanding on C. So it's saying what the things are in that relationship. So this right here and this right here are talking about the same thing, that an investor can own some number of stock. So D is simply elaborating on that relationship and telling you about the attributes of the relationship. Okay. Then E, we had, this was a relationship, and we had the office to which the advisor belongs as a relationship. We already have that an office employs advisors, so that relationship is already in place. And we have an advisor advises some number. The color of the ink is not suggestive of anything. So advises investors. Okay, an office has, F just had attributes. An advisor is associated with only one office. That's going to help us with our, what kind of information is that giving us about a relationship? Multiplicity, and specifically it's giving us both the participation and the cardinality. It's saying it's 1-1. So we know that a advisor is employed by one and exactly one office. And earlier, we'd actually said that an office has a number of investment advisors. In fact, here too it says an office may have multiple advisors. So presumably, this is probably going to be one to many. Okay, the dividend is an attribute. And finally, J, whoops, I don't want to capture ink. Finally, J, a stock gets purchased or sold by an investor and the advisor conducts it. So the last relationship is a diamond between an advisor, investor, and a stock. So call this purchases. So here's the two that you were talking about. There's two here involving investor and stock. Okay, so section E, someone's pointing out section E gave us some multiplicity information. So one or more investors that the advisor services. So it's one or more. And we can fill, if you go back and look, you will find that a advisor can manage 0 to 1 office, that an office is managed by one and exactly one advisor. Somewhere here it says that an advisor, wait. Says an investor has a single investment advisor. So right there, a single investment advisor, therefore a investor has a minimum of one and a maximum of one investment advisors. It didn't explicitly say anything about how many investors may own a stock, but in general, how many investors do we think may own a stock? Is there any limit to how many of our clients could own a stock? There's none, right? Many could own it. So probably one to many. And the reason I'm saying one to many is if it's 0, why bother having the stock in the database? So probably it's one to many because there's no reason to store the stock if none of our clients own it. Now that may or may not be true, but Right. So
Well, it,
you can make, I'm going to say you can make the argument either way, and you would simply ask, this is one of those things, you conduct interviews and say, do we think we need this information or not? So. Oh, I see what you're saying. Well, I guess what I was saying is there's no transactions associated with the investor. Do you need to have the stock? So you're right, William. As long as we have a transaction, we have to have it. So the question really is, if, oh, good point. You're right. Actually, it could be zero to many because it's definitely going to be involved in the purchases. So you are right. But that's a technicality. I would not ding you for saying one. But because the stock is also involved in a purchase, it has to be there. Okay. So now it comes down to figuring out the cardinality of the purchases relationship. Okay, so we first take an advisor and an investor. So how many stocks can an advisor purchase on behalf of an investor? Zero to many, probably. Then if we have an investor in some stock like IBM, how many advisors could have purchased that stock for us? You want to take a crack?
well, each purchase, at least to me, seems like an individual transaction, which means that you're going to have, for each transaction, you are going to have exactly one, advisor and one investor involved.
That is true, but the question is how many tuples for this particular, for this combination of investor and IBM, how many tuples could there be in the, so it's not asking for a single tuple, it's asking how many tuples might there be, how many tuples in the database with different advisors. So it seems like this probably is going to be, there has to be at least one, and probably some many, because as you said, it seems like if you switch advisors, then there could be some tuples in the database with different advisors for the same investor and stock. So Senior kind of asked the same question the other day on Piazza, which is, when we pose this question, it's not for a specific tuple. We're asking how, for this specific combination of entities, how many tuples in the database exist with different instances of that entity.
Wouldn't there be a purchase ID number in the purchases?
There could be, but that doesn't change the fact that with a single investor and IBM, that it may have been purchased by multiple advisors. It doesn't matter. So there's also with branch, okay, think of staff number or advisor number here, advisor number. Each advisor has a specific advisor number, yet an office can have one-to-many advisors.
Okay, so now I see what you're saying. An advisor can have multiple purchases.
Mm-hmm. Yes.
I was looking at it the other way. I thought you meant that a purchase can have one-to-many advisors.
Right. It does. You're right. A single purchase could not have, but you could have the investor could have made multiple purchases of IBM with multiple advisors. It's a way to think about it. Okay, and finally, we have with an advisor and a stock, the question is how many advisor and a stock. So how many investors might an advisor have sold a stock to? Well, you haven't necessarily. I would greatly like that if I've managed to sell every instance of a stock to ever. It's not. You may never have sold IBM to any of your clients, right? So it's actually 0 to many, because it's possible that you haven't sold some particular company to any of your investors yet. So it's actually 0 to many.
You haven't sold that particular stock, and you have an advisor.
Well, but some other advisor may have sold the stock to their investors. It's just that for Greg, let's say IBM, perhaps you never sold that stock to anyone, but maybe me, I did. So for me, it would be some number greater than 1. For you, it would be 0. Okay, so you should be able to figure out the foreign keys based on these relationships. I will post the answer to this question on the website. For the remaining 5 minutes, we have a pair from Fast Enterprise, which is a company looking to hire interns and employees. So many of you are looking either for an internship or a job. They have some information for you.